Hey, this is Mr. Morrison, and today we are going to talk about surface area of cones and pyramids, which was much like yesterday where we wrapped the outside of it as opposed to volume where we filled the inside of it. So the first thing we need to look at is the height versus the slant height of an object. When we talk about volume, we need the straight up height, which is how tall an object was, which would be this yellow line. But when we talk surface area, we're going to need this red line, or the slant height. And the slant height is typically shown with an cursive L, and height would just be H. That's how you identify the two. So this would be L and this would be H. They're slightly different. And just like yesterday, I believe the easiest way to do this is to just tear this object apart piece by piece. So you would start by looking at the bottom of this, which happens to be a square. So the base of it would be 1.5 squared, which would equal 2.25, I think. Let me check my calculator. 2.25 is right. I'm so smart. Then we would need to take apart the sides of it. So you look at the triangles here. So the area of that would be 1.5, which is the base, times 2 times a half, because it is a triangle, and that would end up giving you 1.5. So the area of one of these would be 1.5, but there are one side, two sides, the back three, the side four. So there are 4 sides. So it would be 6. So to find the area of both of them, we'd have to take the sides, the lateral surface, plus the base, add those together. So 6 plus 2.25 equals 8.25 inches squared. Just like before, there's also a formula that you might think is easier or more complicated to work, and this is the formula: S equals B plus F. F is the lateral surface, or to find that lateral surface, these two are really the same. F and 1/2 PL are the same, and P again stands for perimeter. So if we look at the same shape, the base would be the same, it wouldn't change, it would just be this square on the bottom. We would just multiply 1.5 times 1.5, so the base would stay 2.25. However, this would slightly change. The half would be there. The perimeter of this would be 1.5 over here and over here, so the perimeter would end up being 6, and the slant height would be 2. So we'll work out the same, be 2.25 plus, when you do a half times 6 times 2, and end up with 6, and add these together, and you get 8.25 inches squared. So either way, I did it breaking apart piece by piece, or just plugging everything into this formula, you would get the same. And again, this P stands for the perimeter of the base over here, and I got that by 1.5 plus 1.5 plus 1.5 plus 1.5, or times it by 4. So that's how you would do a pyramid. Cone, you can't really take apart piece by piece, you really just need the formula. And again, the cone is a circle on the bottom, so the pi r squared should look familiar. That's a formula for the area of a circle. And then to find this piece right here, when you take it apart, the lateral surface, it's pi r L. So in this particular example, you just plug in the pieces that you know. So the surface area would be pi r, which is 2 squared, and then you plus pi, that same 2 again, and the lateral surface would be that 5. So the circle on the bottom would end up being 12.56, and the lateral surface would be 3.14 times 5 times 2 will give you 31.4, and add these both together for 33.96 meters squared. This you can't really take apart piece by piece. You really just have to use this formula and plug the pieces in. You need to realize that this L, once again, stands for slant height, this red line right here. These can get more challenging, because if I gave you this, the actual height, instead of this, you might need to figure it out. And hopefully you'll notice that the radius, and if you knew this to be 6, and the slant height, it ends up forming a triangle. So at times it might trick you. If they give you the real height to find the slant height, you might need to use Pythagorean's theorem. But again, this was easier, so it gave you that 5. You did not need to use Pythagorean's theorem. You could just work it out. If you could please do these next 3 problems, enter the answers in the Google form. Here's the first one. If you can find the surface area of that, and the surface area in number 2, and this one is one of those tricky ones where you are going to have to use Pythagorean's theorem because it gives you the height. You need to find the slant height, so you'll need to find this before you can really even find the surface area. So if you could answer these 3 questions, they're also saved underneath the form. Good luck.